I've taken the SD card out of my logger, and I'm just showing you the contents of it. There's a whole bunch of files on here. There's lfn0.txt all the way up to lfn17.txt. That means this has been turned on and off 18 times, okay, because we started at 0, but there's also logconf.txt. I'll give you an example of each one of these. Let's open up lfn0.txt. This opens up, by default, Windows opens this up in the text editor like this. And we'll just make the text just a little bit bigger. This first line indicates our initial time, 2021, 9/3/22. Okay, so it was on the 3rd of September 2021 at 22 hours, 20 minutes, 34 seconds. That's the initial time. And then the next one is time duration since the last sample, 670 milliseconds. And then in G's, we get the accelerometer values, 3 of them, 1, 2, 3, the gyro values, the compass values, in this case, pressure, and then we get another time. And so then it repeats. You see time comes up again. And this file goes on for quite a while. In other words, about 21 milliseconds expires between each data set. This was configured to only log accelerometer, gyro, compass, and pressure. And those are the only sensors that this one is set up to do. So that's kind of interesting. The log conf.txt is also important. This is a file that has what we want for the accelerometer. Accelerometer is enabled and its gain value is 3. I'll explain that here in a second. The gyro is enabled and its gain value is 0. The magnetometer is enabled, its gain value is 0. The light is disabled, the pressure is enabled, the temperature is disabled, the humidity is disabled, the real-time clock is disabled. The LED 7-segment display is enabled. The duration is set to 10 milliseconds. And the last file that was the next file, or the last file, is going to be number 18. So if I turn it on again, it's going to create a file number 18. So I don't expect you to write this by yourself and remember this, because these are all in the correct order and they have to be exactly in this order. And the microcontroller actually updates this number every time. So what I'm going to do is I'm going to delete all of those files and show you how we're going to do this. What we're going to do is we're going to use our friend Matlab. Okay? And I've given you 2 different programs. One is called set logger parameters, like this one. And if you open it up and run it, you can run it by, there's a green button up here to press play. And so this is going to open up a window. If we're paying attention, it did it way, way over here. It's still working on it. Okay, and this allows you to set all the parameters that you want. There's a little info button next to each one of these that tells you a little bit more information about each one. And you can read it here in the dialog. But this is really simple. I can select the things that I want to do. If you select real-time clock, every sample, let me do the info on real-time clock. This gives you time resolution in seconds, but keeps tracks of years, months, days, minutes, and seconds. The downside to this sensor is that it takes 17 milliseconds to do a single timestamp. So this one limits how fast you are. It will always count milliseconds between samples, but this will give you definitive date time between each sample. Okay, so there's a downside to doing that one. As all of these add, if we select, okay, this one, it adds, what did we say? So if we select it, adds 2 milliseconds of delay for the accelerometer. So let's just add everything. And I'm going to actually disable the LED. Well, let's leave it enabled. Okay. We can also set our accelerometer range. Okay. If we were going to go really fast, had a lot of acceleration change, then we would want to have up to 16 Gs plus or minus 16 G's on each axis. This is degrees per second on the gyro. And so if we were going to spin really fast, we'd want to have that high. The magnetic range, we can have it up to plus or minus 16 Gauss. So if we're going to use if we're going to use the magnetic north of the Earth, we'd set it at plus or minus 4 Gauss. If we were going to use an external magnet, we'd set it to plus or minus 16 Gauss. Okay? And you can do in between. You can play around with each one of these. There's also a light gain. So if you want to measure very, very tiny amounts of light, we'd set it at times 120, or times 8, or times 1 if we're in a very, very bright setting. So we have everything there. And once we get there, we're going to write our config file, and it's going to ask us where we want to save it. And we're just going to give it a minute. It pulls up a dialog window, which came up on my other screen. And I want to save it directly to my SD card that I just cleared off. I'm going to select this folder, and now, if I look here, we have logconf.txt, just like we had before. But now, our first file is going to be 0. Duration was set to 20 milliseconds. LED. One thing I forgot to show you was the duration, sample rate and duration. This maxes out at about 100 samples per second, or 10 milliseconds per sample. It's going to do its best to keep up with that. It may not be able to do that with everything that we have going on here. If I try to go beyond that, it goes down there. We can go as slow as we want. Okay, we can go very slow as far as what our sample rate is, and it updates the time delay in between each sample. And so I'm not going to write that config file, so I'm going to close that up. I'm very happy with this config file. And now I'm ready to plug this SD card into my data logger and run it. Now, a question. What happens if I forget to make this config file? No worries. The microcontroller will make a config file by default that has everything enabled and has a duration, I think it's the default that we come into. All of these will be 0. In other words, they'll be the initial gain of all of the accelerometer, gyro, magnetometer, etc. And 20 milliseconds is, I believe, how that one goes. So it'll still record data, but just maybe not perfectly how you want to, or with extra data. So I'm going to pull this out of the SD card. We're going to switch over so you can see my camera. I'm going to plug this in, and now we're going to turn it on. And now, as that's blinking, the blinking is what tells you that it's working, by the way. And so as that's blinking, and it's a little bit blurry here on the camera. I wonder if it's better closer. It's not. It's blurry. So as that's blinking, we know that it's recording data. And so what we're going to do next is we're going to keep track of files as we do this. So let's do that next. Let's turn it off. And this file 1, I'm going to record as accelerometer. This is my accelerometer file. Okay? So I'm going to do I'm going to do Z, X, Y are going to be my 3 files. So this is a good example of how we're going to do it. Let's turn it on. So it's recording file 1, which I think is my Z-axis. Remember, that's pointing into the table, and that's gravity is just doing it. I'm very going to carefully turn it on to my X-axis. So now it should have shifted and shown you X-axis. And then finally, I'm going to do Y. And so you got to get these orientations right in your head. Okay, so file 1 was accelerometer. Now I'm done. So I'm going to ZXY XL. Okay. File 2. I can even go up here and say file 0 was a test. File 2, I'm going to do a gyro. And so we're going to have a little bit of fun with that one. So file 2 comes up, and I'm going to try to spin it. Oops. So I messed up. I might want to take note of that. Okay. So that's one axis. Here's another axis. And I'm going to do my file axis, see if it stays. It's not. That wasn't very good. Okay, and we're going to call that one done. For my third recording, file 3, I'm going to turn this on, and I have a magnet in my hand. Okay, and so I'm going to put it very close there, very close there, and very close there. You could also do individual files and somehow keep track of which axis is which. I'm not sure really which one that's going to be, but these are good ways to track those 3 values, and then I'm done. Now that I'm done with this, turn it off, SD card comes out. I'm going to plug it into my computer. We look and we can see that we have LFN0, LFN1, LFN2, and LFN3. Those are the files that we have. Now, the problem that we have with these files is when I open them up, it's not really in a good format. And so we're going to use the second Matlab program called parse logged data files. I'm going to come over here and open it, so it opens in this window, and press play. And once again, it's going to bring up a graphical user interface. Really simple one this time. We're going to select a data log file. And I've got to go down and find the one that's here. I'm going to select 1. That was my accelerometer file. And we're only going to do the accelerometer file right now. It's going to open that. And it's going to, I think I lost it. Okay. Now I need to parse the saved file, parse and save the file. Okay, I'm going to parse it and save it right here, where I'm at, where these are. And if you watch, there's going to be a file that shows up here, LFN1 2021 1022. That's today, 10/02/21.mat. Okay, and I can just double click that, and that loads up my data. Here, let me show you again. I'm going to double, so this is my workspace. This has all my data in it. And we're going to open that, and it brings up Excel data, compass data, gyro data, humidity data, light data, pressure data, and temperature data. Those are all there. We'll explain how to do this in future things, but I'm going to plot the Excel data 1, Excel data 2. The first column, this is the first column that we're going to, is time. The second column is one of the axes. And so if I plot this, it's going to bring up a window that's not on my screen. We can see that it was 0 for a while and then went up to 1G and then came back down. I believe that this was the second data set that I measured. And there's a way that we can find out. Is I'm now going to plot the third column, or the second data column there. That's the third one. Look, it was about 0 and then it popped up to 1 for the rest of the file. I can also plot the fourth one. I'll bet you know what that looks like. That was full 1, comes down, and now we know which axis belongs to which column of data. And so that should help you quite a bit in figuring this out. We can do this really quickly. I'm going to do this with gyro data, and this one's going to look a little bit goofier. Wait for our file to pop up, our picture. It's right here. And you can see right here is when that axis, there's a little bit of here and a little bit here, but this is the big one. I'm gonna do the other ones. And this is really interesting because both of these are registering a big spin on that one. So we'll have to go back and play with this one just a little bit more. And look at the fourth one, and the big spin was here for this one. So I'm not sure really which is which. We're gonna have to go back and figure it out. What I'm really interested in is the compass data. Comp data. And I know this is really small, you can't see it there. There will be a better demonstration of this. And what does that look like? Ooh, we have a big, up to 25 Gauss here, and then it drops down another way. I'm going to hold on that one. Look at the next data column. Ooh, there's a big one on that one as well, where I brought the magnet close. And that one there. It all seems to be the same pattern. I think that they're all correlated that way. And so this is how we're going to get the data off and start looking at the data. If you look at the data, let me just show you the comp, or the Excel data, what it looks like. So there are 3 columns. This is time, this is X, Y, Z, or the 3 different axes. And so you want to look at those. You can tell that this is kind of boring data as we look at it. The other thing is that this is all 1 times 10 to the 7th. In other words, these are very, very large numbers. That's why those come across as zeros. So you got to be careful about that. This first column is in milliseconds is what it's being recorded as. So this should get you started as far as being able to play with data and see if you can get the right things. I will write some code for you to be able to plot using Matlab and have that as a text file for you.